All right, so we took a look at how to do parsing and generation of XML documents from and to Java. But the conversion can also be done at the XML level, right? Instead of us loading it from XML into some Java data model, doing some manipulation, then writing it back to some XML representation, XML itself has a mechanism that can be used to transform and manipulate and deal with the XML documents themselves. And it's XSLT. Right? These are style sheet transformations that allow you to do conversions and encode them in XML itself. Right? So XSLT, or Extensible Style Sheet Language, transformations allow you to, instead of doing it programmatically, like we would do in Java, iterating and creating or removing or doing things like that with if statements and whatnot, this can be achieved the same way by using a declarative language, or XSLT. XSLT is a declarative language that is very akin to what you might be already familiar with in style sheets, right? In CSS. So CSS for HTML is the equivalent, right? It was the analogous idea here, right? CSS does a transformation. It takes the original HTML document, right, and it applies several rules, right? Where you have a set of rules that are compared against the original HTML document, and then once the HTML document matches, or portions of the HTML document matches the rule, the transformation is applied. Whereas in HTML, those transformations are visual transformation, changing the color, the size, the width, the height, the font. Here, the transformations are structural transformations. Right? Maybe extracting a sub element, or adding new elements, or changing the entire hierarchy of the document. Okay, or they're transforming something from XML, and I want a PDF output of it, or I want something that is XML and I want to generate an HTML version of it, or I want to convert it into SQL, I want to convert it into Word document or Excel or whatever. Right? There's many different types of transformations that allow you to go from raw XML to any other representation. Okay, so let's take a look at this. Just recall the original document that we were considering earlier, right, where we had a fairly normalized list of students and their enrollment in various courses. So, for instance, we could declare or create an XSLT document that would allow us to read that document and transform it using XSLT. XSLT itself is XML. Okay, and the root of an XSLT document, just like any other XML document, it has to follow a particular syntax. Just like HTML follows the syntax, right? Where you have the root element is HTML, and then has two sub-children, right? That it's the header and the head and the body, right? It follows the syntax, and it has its own language, its own set of vocabularies. Well, XSLT also has its own structure. The root document is the root element is style sheet, right? And then inside you can have many rules that are going to be triggered and compared against the original XML document, and whenever the rules apply, then the actions are executed for that particular rule that fired. Okay, so you can configure what the output is going to be. In this case, we are going to transfer an XML document onto another XML document, right? Perhaps with a different structure. But this XML could be of many different types here. We can put here HTML, for instance, right? If you want to be able to generate an HTML document from an input XML document, whether you want indentation or whatnot. Here's a couple of rules, right? That are referring to the original document. They're saying, hey, try to pattern match the original document with the following pattern: graduating students. And indeed, if we look at the original document, there is an element that matches, which is graduating students. So when it matches here, it will execute whatever is inside of that template. Okay, see that template? This is giving us what the output document is going to look like, right? If I see graduating students, the following, whatever's inside the body of that template, will apply and will generate whatever content is in there. Same thing here. Here's another rule, right? This same pattern match. Go and fetch all the elements that match student, right? So that means that here there is at least one student, right? But presumably there'll be many students here, right? There might be hundreds of students in this graduating students listed under here, and they would all pattern match this one student template over here, right? So if it pattern match that student, whatever transformation is in here would apply for those elements that trigger that template. Make sense? Right? Now this over here right now is just the name of an element, right? And the pattern matching is trivial. It matches this or this, okay? But you could be a little more specific. You can use and the syntax of what's there, right? Right now is just the name of one element, but it could be fairly sophisticated what we can put in there, right? On what you want to pattern match, okay? And that syntax itself, it's its own language. It's its own language. Just like SQL is its own language, that the syntax of what you put in those two quotes there is its own language, and the language is called XPATH, right? And we'll see that in a minute, right? Okay. So if we continue here in the template, in the graduating students template, notice that what we've done is that we have created the template. We've created what we would want the resulting XML document to be. So we're saying that pattern match graduating students, and if you find it, the resulting XML document should have a brand new student names element, right, with the closing student names down here. Okay, and in the body of that brand new student names element should be whatever template matches the following rule student, which in this case is the one down here. Meaning that I want to put in here inside of as the body of my brand new student names tag whatever this template says. Okay, which right now we haven't seen what's in there. Right? Well, so let's go in there. Let's dig in there. Let's see what's in there. There it is. So in that student template, we've said that I want for every student that matches this student a rule, I want to introduce a brand new element called name. Okay, there's an opening and closing tag name, whose body is right. Whose body is the value of an element called sname, a child element called sname. Right? If you notice the original XML document, the student indeed has a child name, a child tag called sname. Okay, so that means that this is going to retrieve the value of the sname element, whatever it is. In this case, is Ian, right? And so it's going to generate basically an outer student names, and then multiple just name with just the values of the names of the students, right? So the resulting document will be from this input XML document. The resulting document would be this, right? Student names, and then just name, Ian, Ben, Tom, only the names of the students. That makes sense? It's a very trivial example, right? But it introduces what XSLT does, right? You're taking an input XML, taking an input XSLT, it generates an output XML document. Yes? That XML document doesn't need to be an XML document. It could be an HTML document. It could be an SQL document. It could be a Word document. It could be a PowerPoint slide document. It could be a PDF, right? But it all starts with an input XML, an input XSLT, and then some output. And the output usually is XML. That's the most common use case, right? But certainly it can be any quite a few other generating to all sorts of ways. Okay, so this mechanism, the mechanism of creating these rules, these templates, it could look a little bit non-deterministic, right? These are rules, and they fire, right, once they match a particular portion of the input XML document. Okay, if you're not comfortable with rules just firing whenever they match, right, you could take a more iterative approach to the same exact transformation. This one over here is using a more iterative, a sequential approach. Right? In this case, we have the same outer template that matches the same exact starting point of the root of the input document, and it generates these same student names, right? Outer root document, the new root document. But now, instead of having a template there that's going to fire at some point, this one is taking a more iterative approach, right? We're saying we're going to iterate over all the elements that in the input XML that match the following rule, student, that match the element name student. For each one of those instances that match, we're going to generate a brand new name element. See that? You might prefer this style or the other style. Okay, they both are equivalent, right? They both would generate exactly the same output. Right. Right. So transformation, you don't necessarily are transforming just XML to XML, but you can transform between various representations: PDF, Word documents, SQL, HTML. So here's an example of taking the same exact XML document, but with a different XSLT. Right. This XSLT will generate instead HTML instead of generating XML. Okay. So same thing. It starts with a root style sheet element. The output, we're saying that it's HTML instead of XML. Same pattern match. We're matching the top graduating student's root, right? And when we find that, we're gonna create the following output. We generate the following output. We're gonna open up an HTML document, a body. We're gonna open up a table. We're gonna create a headers for that table. Okay, for headers for that table, and then gonna close the table, the body, and the HTML. Right, but for the body of the table, what we want to do is to generate one table row for every single student that matches. Right. So to do that, we're going to apply and select students. That's going to pattern match against this rule down here. And so for every student that matches this rule, we're going to generate one table row. See that? In that table row, we're going to have 3 columns or 4. I don't know, 1, 2, 3 columns. The first column is going to select the value of the S name. The second column will grab the graduating year. And the second one, it's actually going to execute another a pattern, right? It's going to take a look at the courses. If you remember, courses, right, are all the courses that the student was enrolled, right, for that particular student, right? So basically, in this TD, maybe how do we want to represent the list of courses? Maybe with a list of the courses, or maybe a nested table, perhaps. Okay? So nested in there. Notice that courses creates yet another table. So this is going to be a nested table, an outer table, right, with 1 row per student. But in one of the columns, we're going to nest another tiny little table in there, right, with all the courses listed under there. So there's a table. And under courses, we have a child course. So we're going to apply for each course. There it is. We're going to generate another row, and we're going to extract the title, the year taken, and the grade. Okay, so two nested tables, right? So an outer table and then a nested table with the courses in there. Yes? Right? That makes sense? Right. So again, the language by which we define whether we choose what pattern match, that language can get pretty sophisticated, right? It's the expression that goes in those two quotes there, right? It's XPATH. Right now it's trivial XPATH. Right? We'll look at a little other examples in a minute. How about generating SQL? How about so we've seen the example of one input XML, one input XSLT, and generates an output XML. We saw that, right? In the second example, we saw an input XML, input XSLT, and it generates HTML. Right? But this one, for instance, can generate SQL, right? So how about what I would like to be able to do is take the original XML document, take the original XML document. Maybe I want to insert it into a database, right? So for instance, given this input list of graduating students, right? Maybe hundreds or thousands of students. I like to generate all the inserts, right? SQL statements that would allow me to just import it into my SQL, and I would have it inserted into a table called maybe course taken with the applicant's name, the title, the grade, and whatnot, and the values, right? So convert it into a different representation. So here's another XSLT. Again, it starts off with pattern matching the graduating students, first the students, and then the courses. Here, notice that first we're going to insert all the students, and then we're going to insert all the courses, right? Because we're going to, just like in XML, it was a denormalized, fairly hierarchical representation. Yes, we're going to do something similar in SQL, right? We're going to have one table for the students and one table for the courses, and perhaps foreign keys and primary keys pointing one to the other. So in this one, we're going to pattern match graduating students, but for this one, we want to pattern match for the courses inside each one of the students. See that? So here's another example where XPath is getting just a little bit more, involved here, right? I don't want to look at all the courses all at once. Instead, I want to see each course inside of every student, right? Which is a little bit different, okay? Because I want to know the course within the context of the student that it's in, right? I don't want to just see all the list of courses, because then I would lose which course is inside of which student. Right? I want to remember, as I iterate over the course, I want to know where are you, in which student are you in. Right? So here I'm saying I want to iterate over the courses inside of each student. Okay, and so there are two different templates. So for the student, we're going to generate the output is going to be an insert statement into the applicant table, and app name and applicant name and graduation year. I believe I've removed a lot of things here because there were several other fields, but the example only contains the app name and graduating year. Then it generates the values, and the actual values for the applicant name will be the selecting the value of the child S name element, right? Or selecting the graduating year element value, right? So this will generate all the inserts into the applicant table, right? For the courses, okay, we're going to generate the course taken, the applicant's name, title, grade, and for the applicant name. So this, I believe, this is just a foreign key back to whose course this was for, right? Notice that I can traverse, since I am inside of a course, inside of a course list, inside of a student, right? I can navigate from within the course. I can go back to my parent, right, and retrieve the elements S name from within the course. So if you go here and you're inside of a course, I can navigate back to the student courses, go back to the student, right, and then down to the S name, right, as I am iterating over each one of the courses for each one of the students. Make sense? Again, another example of using an expression here that allows us to navigate the hierarchy of where we are, right, in the current XML document, and be able to exactly select which elements do we care about, right? Here we're using navigation, right, that we can navigate the hierarchy. Again, an example of XPATH, right? XPATH allows you to navigate the hierarchy. So XPATH, so finally, XPATH. So all these expressions that we've seen so far, the match and pattern matching an individual element, or pattern matching a hierarchy in a particular element in the hierarchical of the hierarchy tree, or navigating up from the hierarchy tree. Those are all examples of XPath. So XPath has its own syntax, right, that allows you to you navigate to the current node, going up one or down one with slashes, or pattern match an exact name for node name, or extract the attribute. If a node has an attribute, you can also select a particular attribute in that node. It also allows you to navigate up and down, from one element, either relative to the current context of where your iteration happens, or absolute, right, from the root of the document, or select follow a particular branch, right, in the XML hierarchy, or select all the books wherever they appear, right? I don't care where they appear, anywhere in the document, right? Or select an attribute wherever it appears for any element. Okay? It allows you to also if you have several of these listed, you can refer to a particular one at the beginning or the last one, or any one of the siblings, right, by an index, right? Very, very similar to what jQuery does, right? You can ask an index and you say, all these elements that are siblings to a parent, right? I would like the first one, the last one, or the nth element, right? Or that it matches a particular criteria, right? I want the first three, the last three, right? Or starting a particular index, the next three, right? So it's very, very powerful. Or it allows you to also filter and say if there's an attribute, right? If there's an attribute in that element, I like to compare it against something, right? If it's greater than a value, is it equal to something or less than, or is it in between, right? Or does it start with, or does it end with? So it's fairly complex on what kinds of predicates you can build, right, to be very specific on what elements do you want to refer to, or you want to pattern match to trigger the template. So let's use the XPath to restructure a document, right? So here's the document that we've been looking at so far, the graduating students. That perhaps it's fairly hierarchical, right? But another one of our partners would prefer this XML document to be perhaps a little flatter, right? Or maybe our partner gave us this very hierarchical, very denormalized representation of the XML document, but we need it to be flattened because we need to map it to some Java data model, right? That has a specific schema. So we can use XPath to iterate over all these students, right, and flatten it out. So for instance, this XSLT flattens the tree, right? It pattern matches the graduating students, and then it pattern matches all the courses inside of those students. And it just generates the original enrollments table. I don't know if you remember the original enrollments a document way at the beginning of the presentation. I think it was here, right? It was this one, the enrollments. It was very flat, right? It just had all the enrollments and then who and the courses that each one of the students took, right? So it was very flat. So let's generate that. Where was it? 62. So here's the enrollments, and then we're going to iterate over the courses. And as we iterate over the courses, we're just going to generate one single course taken element, and we're going to either refer to child elements for the course, title, year taken, and grade, or refer to parent elements, right? And take the name of the student, the name of the graduation, the graduating year, and whatnot. So this can transform between these two representations that are equivalent to each other. One is denormalized, the other one is a denormalized representation of the same exact data. Okay? Or you can do it backwards, right? Go from a very flat representation and go back to a more a normalized representation, right? So for this, here's the original input, right? The enrollments and the courses taken, and we want to generate that nice normalized representation. So we pattern match and start with the enrollments. If we find the enrollments, we open up an opening graduating students, and then we're going to iterate over all the course takens, right? And the course taken, we have several attributes. We have the S name attribute, the graduating year attribute, the title, the year taken. We need to convert all these to elements, right, from attributes. So that's what we do, right? We're going to iterate over all the course taken, and we're going to group by S name, right? Because if you remember, right, in the original representation, it was one entry per student, yes, right? And inside there, we had the courses taken for that one student. Whereas the new representation is a denormalized representation where the student appears multiple times. Yes? So what we'd like to be able to do is to aggregate, right, all the instances of those students that match, that have the same name. Right? Because we only want one representation, not 3 or 4 for Ian. We want just one. So we can use group by, right? Group by is again XSLT, allow you to find all the input elements that are grouped by the attribute's name, S name. In this case would be Ian or Ben or Bob, right? And for each one of the groups, we can generate a single student element, right, per group, and then generate in there the student name, right, which is going to be the value of the student name, the graduation year. So notice that we're generating the student name, the graduating year, right, a single entry. And whereas for courses, we need to iterate over the original elements, right, that matched, that are grouped together. We need to iterate over all of them. So we can grab the original elements and iterate over them and generate as a multiple course entries per element in that group, and generate the title, the year taken, and the grade that you took, right? This allows you to very much like in SQL, right? If you have multiple elements that can be grouped together and aggregated, this allows you to do something similar as well. Again, all these are expressions and examples of using XPATH, right, to refer to groupings and aggregations and whatnot. Okay. You can also reference attributes, right? As we saw examples, we can use the ampersand, the @ sign, right, to refer to attributes inside of elements by names. All right, so let's look at how would we use XSLT and actually do some of these transformations right from Java. All right, let's take a look.